And we'll go over to Swansea to join Becky and the panel of material science experts. Becky.
Thanks, Chris. Hello, good afternoon, everyone. Welcome to this live Discover Materials This Winter question and answer session around the topic of the impact of materials with our panel of real-life material scientists and engineers who are here to answer all of your questions. I can see some of you in our audience this afternoon. So before we get started, we'd like to do a quick test of the Q&A box. And this can be found at the bottom of your screen marked Q&A. If you can open that up and type in there who you are, where you're joining us from, and we can make sure that the Q&A function is working properly. So that Q&A button at the bottom, tell us who you are, where you're from. And if you've already got some questions about material science and engineering that you'd like to ask our panel, please add them in there for us now as well. My name's Becky Waldram. I'm part of the Sustain Steel project, which is based at Swansea University. And we're one of several universities in the UK with a materials department, which make up this Discover Materials group, which you've been hearing from today. I have a degree in sports materials engineering, as well as a master's and NGD in materials engineering from Swansea University. And now, as part of the Sustain Steel Hub, a lot of my work focuses on sustainability in the steel industry, developing cleaner, greener and smarter industry, which is fit for the future. I do a lot of work through outreach and public engagement, and also trying to raise the profile of and general knowledge around the subject of material science and engineering in the UK. So this session is all about you, our audience who have been listening to all the talks today. This is your chance to ask us and our panel here any questions you might have, from what subjects to study at school, what options are available at university, to careers and how you find a job and what these jobs in materials are really like. So this is all about you. Please remember to add any questions and comments at any point in the session into that Q&A box that I mentioned at the beginning, and we'll try and get through as many of these as possible during the session. If you're following along on social media, then please share your own experiences using our Discover Materials Winter hashtag. We'd really love to hear what you think and any reflections you've got on today's session, any of the sessions that have happened earlier today. So let's get started. I'd love for you to meet our panelists today. I think all of whom have got their cameras on now and are here waiting, ready to go. So we've got Ilia, Zoe, Abrima and Amy. Hello and welcome to the panel. So to get us started, I'm just going to go through our panelists and ask them to tell us who they are, where they're based right now, and give us a little bit of background about what they're working on right now. So I'm going to start with who's first on my screen, and that's Ilia, if that's okay.
Great, yeah, thanks very much, Becky, and hi everybody. It's always nice to see plenty of people who take an interest in materials. So my name's Ilia Schwich. I'm a lecturer at the University of Birmingham in materials and natural sciences. So the two things are I suppose related very much to each other, but I joined Birmingham about 3 years ago. I have a particular interest in carbon nanomaterials, so how we can manipulate carbon at the very, very smallest scales for all sorts of interesting things, particularly in medical applications. So I've really enjoyed Chris's video that he's playing, and when it talks about the combination of different subjects. But I also have a real keen interest, I mean, as Becky said, in terms of raising the profile of material science, both within the UK and internationally, because it is fundamental to the modern world. And it's also an absolutely fascinating subject to do. And it's very, this word which is bandied around a lot, interdisciplinary. And so that's where the natural sciences part of my job comes in. And I focus a lot on kind of how we can better encourage and better facilitate interdisciplinary education at an undergraduate and postgraduate level.
Brilliant, that sounds really interesting. Thank you very much. Next on my screen is Zoe.
Hi everyone, nice to be joining you. I'm in London at the moment. So I am a material researcher, developer, designer. I have a background actually in the arts and then have moved into material innovation, science and engineering, working on different collaborative projects, international projects, community projects. And so, yeah, I think that is probably a good enough introduction, Becky.
Yeah, no, that's brilliant. Thank you, Zoe. Next on my screen is Abrima.
Hello, everyone. Thank you, Becky. My name is Bryan Masala. I am, I'm finalizing my PhD, engineering doctor student at Swansea University, studying materials. My sponsor company actually is Tata Steel. They love to make steel, but steel is not my material. My material is actually what we use every day: tea mugs, ceramics. That's the clue. So I am basically, yeah, that's it. It keeps us warm, doesn't it? So I actually study this material, and I'm actually interested in the carbons in the material, just like the lecturer spoke to before us, I think Elijah, mentioned about carbon nanotubes. So my carbon is graphite, and I'm really interested in the properties that it gives this material, and I'm using carbon as my sensor to understand the mechanical behavior of the material, and then give my sponsors some useful information that they can utilize to save money on cost of that material, and to prevent failure, because failure is a big thing about in material. Studying failures is an amazing aspect. But I came from a medical health background, so I did biochemistry as my undergrad. I happened to find myself in materials by sheer luck. A friend of mine who used to work for my sponsor company encouraged me to actually apply for the engineering doctor scheme, and that's how I found myself doing it. So yeah.
Yeah, brilliant. Thank you. It's great to have you here. And finally, we have Amy.
Hi everybody, thank you for coming today. My name's Amy and I work at the University of Birmingham, and I'm a characterisation technician, and I manage the equipment that's to do with characterisation and sample preparation. And before this, I was actually a microbiologist working for Muller. So thank you.
Wow. A nice varied background there we've got from our panel. Okay, so let's get started on a few of the questions. Reminder to our audience, get those questions in using the Q&A function. There are no silly questions. We'd love to hear any comments, any thoughts that you have. So I'm going to start with one I've got. Everyone has a different route into materials, as we've already heard in the introductions. Personally, I hadn't heard about the subject until I was looking at applying to university, and only actually went on a materials course because I didn't get the A-level grades to do a mechanical engineering course. So I was offered a place on materials through clearing and decided to give it a go and see what it was all about. And for me, that's one of the best things that's ever happened to me, was not getting perfect A-level results. So I'm really interested to hear from you. I know some of you have already touched on this, but was there something in particular that made you become interested or involved in material science? Was there a moment while you were studying or perhaps working on a project that may have been nothing to do with materials, that thought, oh, is that a subject? Can I get involved in that? So it's quite a big question, but if there's something in particular you can think of that got you interested in the subject, please unmute yourself and let us know. No one wants to start.
Well, I was going to say, shall we? If we go in order, and I'll try and not ramble on for too long. Yeah, I mean, it's a fascinating thing. I think so many people, as Becky just said, fall into it without even knowing, and I mean that's a fundamental problem which I really want to try and help solve, because I was exactly the same. I had never heard of material science and engineering until I opened a university prospectus and I saw it and I was like, oh, okay, that sounds really good. Because I was always looking at, I loved physics at school. So A levels, I did physics, chemistry, maths, and French. I always think it's good it's just useful. It's nice. I enjoy studying languages. But I always thought, oh, you know, it'd be a really cool degree is physics and philosophy. I've always thought I'd be able to balance two different things there. And start, you know, probing those really interesting questions about the universe and the world and everything. Now, I don't know what it was. I saw materials and it was love at first sight, whatever you want to call it. It just really struck me as something which was very, obviously it covered a broad range of materials, which I liked. I didn't want to, I mean, as you can tell by doing sciences and then French as well, I hated pigeonholing myself into kind of like one compartment, like, oh, I am a chemist or I am a physicist or something. And also it had what I was really obvious was it had a very strong practical hands-on element. And so, yeah, I mean, when we talk about inspiration, so my dad he's a machinist. Ever since he moved to the UK, he's been a CNC when computers finally came around, but a miller. So I had experience of, you know, the smell of swarf and kind of working as well on the floor with metal for a few years before I went to university. And I really like that practical aspect. And I think that's really how I fell into it. And other than that, I'm still annoyed that my only exposure to materials before that at school was in a physics course. It was really fun. I was looking at, we had to pick a material and kind of, you know, draw some stress strain curves and discuss why it was used in this application, but that was it.
Yeah, I remember in a physics class we had to like cut up plastic bags and we were adding masses to the bottom to look at ductile behavior of materials, but that was classed as physics. We didn't know that it was anything to do with materials. I think you touched on this as well. It is that segregation of subjects, especially in secondary school, that you do physics, you do chemistry and you do biology, and you don't really see what the links are between those subjects unless you want to investigate them further. So that's really interesting. Zoe, have you got anything different to add there?
Yeah, I definitely have a different, have had a different way in, because I was always kind of humanities based. I did art, drama, English, languages, really enjoyed physics, was very good at maths, but didn't really know how to use it in that sense in related to materials. So materials for me was textiles, making, you know, hands-on fabric. I didn't really think about materials in any other sense, but it wasn't until later on doing maths and selecting textiles at the same time that the engineering of textiles, that was something that came in, and then I kind of knew about it, but I wasn't in that kind of route then. So I did at A-levels, I did maths, Spanish, art and textiles, or it would have been more like design tech. And so I came in from a completely different angle, and it was only later when I, you know, was working in industry that I was kind of getting more involved in the innovation side, properties, characteristics, that designers, that artists were talking to me about, and actually then realizing that I was joining those dots. And then so started working more with engineers and scientists then, and having that kind of interdisciplinary role that needed to kind of connect everyone and communicate with everyone between them. So that's sort of what I'm doing now, and try to encourage as much as anyone wants to go into that, you know, one field. I say, oh, it's good if you can do a few different things, and, you know, open it up and never feel that it's too late. Like I struggle calling myself a material scientist, you know, struggle. I'm like, I'm an artist, but what I'm doing doesn't relate to that. So it's really interesting. Yeah, it's really interesting to hear.
I think it's interesting as well. You say like in industry, they don't necessarily realize that what they need is a material scientist or engineer as well.
They have no idea that they're you know, they're kind of relying on businesses to tell them what they should be using, and not having the information behind it, or businesses being able to, someone else being able to tell them, but not knowing what that role is, not knowing that they need it, you know, to help make decisions, good informed decisions.
Yeah, and I think there's something with a lot of tests being called mechanical tests. A lot of people assume they need a mechanical engineer, whereas the test itself absolutely,
which can be useful sometimes, but still.
Absolutely. But yeah, it's just the name of the test doesn't line up with the type of engineer or scientist that you necessarily need for that. Yeah, really interesting. Bryan, have you got anything to add to that?
Yeah, kind of similar to what Zoe was saying as well. I've always had this open mindset. I never knew what I wanted to do when I was in college. So mostly I actually sought advice from one of my teachers, and he said, you know, I suggested to him biochemistry because I know a family member who did that for their undergrad. And I said, what do you think of this subject? And he was like, yeah, that's a fantastic subject. Why should you should apply for it? And then that's what I did. So no one actually introduced me to material science at that stage. I think going back, because I did my secondary school in Africa, so I'm from the Gambia originally. In my secondary school, I was a bit artistic as well. So we used to do things like tie and dye. So this is basically a method of creating a pattern in a textile material. You're using candle, you're melting a candle, and you're creating patterns using ropes and stuff. And then you sort of like take the material and submerge it into this hot molten candle, and you take it out, and then you put it into a dye, and you get different patterns. So I tend to love that patterns. And when I discovered materials during my NGD, I kind of understood the relationship between my past experience with textile and art and how it relates to materials. So everything about materials is patterns. And as long as you understand those small patterns on how they relate to behavior, you can actually understand what's going on. So it is like everything around us, but we just don't know, we just don't have the labels for it, basically. We're just not saying this is materials, but you're always doing it, or you're always seeing it, or interacting with it. So I think it was something I was bound to love anyway, but it's just that no one's ever like introduced me to it in that sense. But yeah.
Yeah, absolutely. I remember in our NGD we do like courses on corrosion, so looking at how metals degrade, and then for weeks after that, every time I was going around, someone like, oh, that's rusted. I wonder why that's rusted. And once you know about something, you see it everywhere. And like even all of us sat here today, think about the technology that goes into laptops. But even if you think about like I've won a table and chair, someone's thought about what's this table made of? Can it support my laptop? And all these sort of things. Once you start to think about what materials is used for, you just don't stop, because it is absolutely everywhere around us. Yeah. And Amy, sorry, we've had some very detailed answers there, but have you got anything else you'd like to add on that one?
I suppose for me, what led me to material science, before I was a microbiologist for a yogurt factory, and I was always interested in how we characterize them and those different techniques. That's what kind of led me to the university and for the materials itself. Also, my granddad, he was a researcher when he was alive, and he was working in batteries and rubbers. And I also come from Shropshire, and it's the birthplace of Industrial Revolution, so it's in my blood.
It's amazing. I found a lot of people in science and research, do you have either a family member or a close friend that have been quite involved as well, which seems to be a really big influence on whether someone's interested in the subject as well, which is really nice to hear that family and friends play that bigger part in what people decide to do. I guess we're trying to be some of those friends to push people into materials so that people know what it's all about. So today we've talked a lot about, in the talks that we've been through, the impact of materials has been kind of the theme of today's talks. So I just want to put this one to you. How big a role do you think material scientists and engineers can play in developing sustainable solutions from the future? I think this is quite a wide one, because obviously there are lots of different avenues we can go down with this. But is there anything that particularly any of you are working on which might play a role in sustainability in the future? If Ilia's got something, go ahead, but I'm happy to go to someone else first if he needs a bit more time to think.
I mean, I could think for the whole time and probably still not come up with an adequate answer. So I'll just go with I mean, the generic answer without going into a specific is that irrespective of whether you're focusing on like projects aiming towards, say, net zero or making a more sustainable world, as I said, like material science is absolutely fundamental to everything. And you look at, I mean, there's a reason why material scientists are so employable and why our graduates have such high exit salaries. It's because people want material scientists. And no matter what field or what specific project area it's in, I mean, given the push and the correct need to improve a vast range of technologies to make us a more sustainable world, that kind of demand for material scientists is only going to increase. And I think just one area where we can maybe add something a bit more concrete here is, and it's not concrete, is around solar cells. So, I mean, we are looking for when you look at actually how electricity is generated around the world, the vast majority of it is still fossil fuels, right? So that needs addressing urgently. And if we look at solar cells, I mean, it's a lovely example of where, say, different, not only technological issues arise, but there are political problems, there are funding issues which arise on this, in terms of people often quote, oh, you only need to cover this much of the Sahara Desert in order to power the whole world. But then there are distribution issues around this as well. But a material scientist can play a role here because there are lots of technologies. We can look at, for example, about two, say, flexible solar cells that could potentially go onto, let's say, moving vehicles. or perovskite solar cells, which are, these new materials that are basically offer potentially better efficiencies than what we can currently get. But they do not work at large scales. We haven't quite got there. And that is fundamentally a materials problem. A material scientist at various stages along that supply or that production line can offer insight. And when I say a material scientist, I mean like thousands and thousands of material scientists. And the sooner we get these people working on this, the better.
Yeah, absolutely. Yeah, totally agree there. I know, Zoe, you're going to have some interesting insights on this one, so I'll pass over to you now.
I'll try and be succinct, if that's the right word as well. Yeah, so at the moment I've been looking at an area of materials which is regenerative, and one of those areas is biomaterials or biopolymers. So essentially looking at materials which can be compostable, potentially actually have not just a neutral effect on the environment, but a positive effect on the environment. So those nutrients go back into the cycle. And so things like, imagine if you had a biodegradable, or compostable bag that actually had nutrients. So when you threw it away, you actually had additional nutrients that could go into an area. And that has a whole load of different areas of testing that could go into. But there's obviously, with the plastic pollution happening all over the world on different levels, different scales, different locations, it's a really big area of research happening at the moment. And there was a great talk earlier actually on that. So if you didn't see it earlier, I would recommend going back and looking at that. And I think it's one of those areas that there's a lot of new products, a lot of new materials coming in that still need to be tested. Different countries have different areas of legislation, different rules, but there's so much testing to be done, and there's so many materials to make and so many ways which could help our current usage of materials, or overusage or slightly incorrect usage of some of these materials that we're currently using or have been using for the last 100 years. That I think it's one of those definite ways that I think if you're, in any way a kind of eco warrior or worried about what you're, what's happening around you, I think it's a kind of a nice balance between so many different areas that I think will be really vital in the future. Yeah,
definitely. It's just two different viewpoints already. So Bryan, where can you take us on this one?
Oh wow, what can I add? The two, you guys have covered most of it, to be fair, all the things I was thinking of. But one of the things that sprung to mind is actually the fusion energy for the UK. That's a big research. So what the fusion is just they're trying to recreate the sun's energy. So the sun is pretty hot on the outside, but in its core, it's actually really hot. I think it's probably 5, maybe millions. We're talking about 0.000 Celsius degrees hot. So it's really, really hot. And they're trying to use that, or trying to create that. And they need materials to do that. They need super strong magnets to actually just hold that thing, because it's really hot. And it's amazing because I'm actually in that facility. I've won funding to just do some of my work in one of their research facilities here currently. I'm in a hotel at the moment, not in there, but the period. But yeah, they are doing some fantastic work, and they have a lot of material researchers. And what really amazes me is not just the new materials that are going to build this thing that's going to help us get better energy to replace fossil fuels, but it's just the various people and the skill sets that you have to be able to do that as well. It's amazing. So material scientist is just sometimes often looked at as one particular role. You got to have one particular skill. No, it's not. It's so varied. Everybody has this. It's the practical skills that you get from it that I think that's what amazes me as well. The people that are going to actually create this future that we want, we're already here and we're working towards it. So if it's fusion, we're working towards it. If it's wind energy, we are working towards it, and the materials are there. We just need to improve upon it. If it's solar, we're also working on it. So I think the future looks really promising. And yeah, and I just, hope to play my part, however small that may be.
Well, it's like you said, I think materials is such a broad subject that even if you study materials at university, there are still so many different areas you can specialize in. You're not kind of pigeonholed into one area. You can still move around. I think, like Ilia said earlier, it's the interdisciplinary aspects are definitely a strong point of material science. Amy, have you got anything to add to the point on materials and sustainable future?
Well, I definitely think that material scientists are going to be critical in the future in helping to solve our problems in relating to energy and all of the other issues that we've currently got going on. Just want to speak about some of the research projects that we've going on in our department, such as looking at the materials that are building wind turbines, looking at materials for solar panels, materials for batteries, hydrogen energy storage, and recycling rare earth metals as well. So you can already see that we're making great progress towards those steps.
Yeah, that's such a broad range. Just those few projects you've mentioned cover so many different areas in the area where material scientists can help. But you get, advice from other disciplines as well, but the core work there is all happening in materials. So that's really interesting. So we're going to go back to, so any students listening, there are quite a few books and resources out there about material science and engineering. As Chris mentioned earlier, hopefully with Discover Materials, we're launching a new website towards the end of January. I just wondered if our panel have got any books or websites or anything they'd recommend if people would like to learn more about material science or anything about their subject area they cover in materials. So I'm going to go backwards on this one, if that's all right. So if I can come to Amy first.
A book off the top of my head, I'm not completely sure, to be honest with you.
No, just if there's anything you've come across, any blogs or anything that discuss materials, just out of curiosity, if there's anything you think would be of interest to students, or any good areas of reading around sustainability or anything you've come across.
I can't think off the top of my head. I'll pop them into the comment box.
Yeah, of course. Sorry to jump on you first. Bryan, have you got any?
In terms of, I'm trying to think about outreach because I'm really into, well, I've discovered that I really love outreach recently, the past 2 years, I think, because of my interaction with schools and stuff. But I'm just trying to remember what sources I go to. There's a ceramic website because I'm into ceramics. I think it's Ceramic American Society, if I'm not mistaken, and they have free resources, teacher resources. And I actually go into those resources to dig in to get information. And it's so self-explanatory and it's so simple. They talk about rockets entering the earth and how it's so hot when they're re-entering the atmosphere that, you need strong materials to protect it. So these are the sort of things they talk about. And they talk about how to interact it with, if you've got family, children at home, you want to interact, they give you step instructions basically on how to use it. So I would recommend that. I'm not sure if the name is right, but I think it's American Society, Ceramic American Society. If not, I'll put it in the chat box later on.
Yeah, we'll get all these together after the session, and make sure we make a list somewhere on our website that people can check out afterwards, if you're interested. Zoe?
So quite a few different ones. So there's if you're interested in exploring and experimenting with some biopolymers and composites, so materium.org is a really good one because they are an open source research platform, contributors from all over the world, and there's a distributed design platform. And what's really interesting with that is that they've just created a Gitbook online handbook, and I actually asked a bunch of people from lots of different disciplines if they could give me a hand on looking at how you record an experiment. So even just that process of how a scientist and an engineer and an artist or designer might record their experiments or their notebooks, their lab books. So that's got a really nice resource on it. There's another project called Reflow Project, which looks at the kind of circularity of different cities, 6 cities across the EU. One of them is looking at waste heat, whereas another one's looking at waste food, another one's looking at plastic. So it's kind of interesting that they're already kind of being broken down into these material issues across different places, and that project's been going on for 3 years. So there's loads of resources there. And there's probably a whole bunch for the books as well, and social media that goes along with it. So I'll do the same and add some links too.
Oh, brilliant. And finally, Ilia, I can see you've been analysing your bookshelf next
Yeah.
to you. What have you got for us?
Yeah, exactly. Well, most of my materials books are actually in my office rather than at home. But no, that I always think is interesting when it comes to. I love reading, and I mean, which is good if you work in a university. But it's one thing I think before you go to university, maybe to study materials, like learning the science stuff, you can be inspired by books, but until you do it, you don't get that real feel. So I think the power actually of some of and probably the book that I'm going to recommend, and I now can't remember, well, there's two. The books that I would recommend are actually those that kind of that touch upon maybe the broader implications of materials research, and or kind of how a scientific and engineering mindset can actually benefit society at large. And I think that's really important because yes, you may come and do a material science degree, but not everybody then goes on to work actually as a material scientist. But you will be very, very well equipped to work in different things. So there are two. The first one is actually, well, I won't bother getting it out. It's a classic textbook which might be recommended when you join a course. It's not even a textbook, sorry, it's just a book by J.E. Gordon on structures. It's quite maybe dry, but I think it gives a really nice traditional overview of like what the fundamentals of materials actually are, the questions that you kind of are looking to ask. And then the other one I'm going to recommend for kind of that mindset of thinking about what skills you can take forward to other careers and also just into society is How Bad Are Bananas by Mike Berners-Lee, and looking at the carbon footprint of everything. And the reason why I say that is, yes, okay, from a sustainability point, it's quite interesting, but that ability to do kind of back of the envelope calculations and estimations and kind of consider different potential avenues of how a complex system might operate is something that material scientists are really good at. So I highly recommend that one.
That's the second time someone's recommended that book to me, so I'm going to have to get it now and find out what it's all about, I think. So we've got just under 5 minutes left. So I've got one more question. Well, it's kind of two questions. You can answer whichever one you'd like to. The first one is, do you have any advice for anyone who's thinking about studying material science, and or what's the best part of working in materials? So you can pick which one you'd rather answer out of those two. Amy, are we all right to start with you on this one, please?
Yeah. So what do I find the best part of it is just characterization, really. I like to know what is exactly happening in the material, why, and how can we change that to increase whatever specific parameter we want about it. Advice that I would give to someone who wants to study material science is have a look at all of the different options of all the different materials that are available. Get into your science and your maths and speak to people. Yeah.
Yeah, no, that's great. I think because everyone has different experiences, you know, we've got 5 of us on the panel here and we all have a totally different view of materials and how we came into it. So absolutely speak to people, email the universities.
I think the more people you speak to as well, the more different experiences that you have, the different opinions of, and you can make your own opinion from there.
Yeah, and if you think you like something when you start, it's okay to change your mind. Say you think you like plastics and then you get to university and you actually think, oh, these ceramics are really interesting. You can always change and switch between the different materials as to which you find the most interesting. That's my favourite part, is breaking things and analysing how they've broken. I agree with that one. Bryan, have you got anything to add?
No, not really. Similar to you guys, really, just breaking the materials, understanding what's going on in the material. It's just a curious mind. If you've got a curious mind, it's really there for you, no matter what skill sets you have. It's one of those things you just have to find something in you because you're unique, and there's something in you that's unique that can actually be beneficial to society. So as long as there is something that's interesting that you like to do within the sciences, it's an area that you should definitely explore. Yeah.
Zoe, anything to add there?
Yeah, I say definitely pick a science subject or maths and your A levels. So you just have the qualifications to get in mainly. That's a good one. But also don't rule out some of the other subjects. The arts in terms of being able to draw or the kind of CAD learning that you can get. Even just drama and English, just to be able to communicate, because it's so important to be able to communicate and also write about materials, and that's a really big part of it. But yeah, I kind of say to get the minimum. And I think my favorite part is probably working with the people. Like, I've been working on a project the last 6 months, but because of the pandemic, we've been working at a distance. We're working in South Africa, and it's a community project called Future Matters, and we really are looking at those kind of future matters, but also the material, or the matter is the material as well. And so that's that concept is really there, and we're an interdisciplinary team, and so that working with a team which is so multidisciplinary is amazing. And I think that's probably the best part of it, even when we're all material scientists and researchers and engineers, and we also have different opinions, but we are able to understand one another and communicate with one another about what we need and what we're looking to achieve. So I think that's the kind of the biggest thing for me, is working with the other people.
Yeah, brilliant. It's a lot to do with the people you work with as well, that's for sure. And finally, Ilia, anything to add on the end there?
Other than to kind of maybe summarize what others have said already. Sorry, I just got an email that my Christmas drinks have been cancelled. That's quite sad. So yeah, two things. The thing that I love most is that you can meaningfully communicate and work with a huge range of people, and by being trained as a materials scientist and a materials engineer, and we could have a different conversation at some point between what's the difference between a scientist and an engineer. You can then specialize, or when I say specialize, you can go into whatever field you actually quite frankly want. And I always use the nice thing of, as a material scientist, once you finish a material science degree, you could go into the kind of, let's say, more mechanical engineering side of things, or equally similar, like what I did, you could go into the more kind of chemistry side of things. If you took either of those degrees, you would not be able to do that as easily. And I think when you this idea of communication, I can again meaningfully and confidently communicate with a very wide range of experts in different fields, and I feel comfortable and I get a lot out of that. So I think linked to that, my advice, Zoe, obviously, you have to make sure you get your prerequisites, but otherwise just keep up to, and the word that Bryan said, which I think is really important, always maintain your curiosity. And always be driven by the questions that you actually want to answer, because material science will actually help you to answer them.
Yeah, I think curiosity has been a big theme of today throughout the talks as well. So I think that's a great way to end this session. We've heard from 4 quite different people who are involved in material science and engineering in their 4 different ways and different applications. So I hope that's given our audience an insight into the variety of projects and jobs you can get involved in if you get a material science and engineering degree, and everything has a material science link. So I just want to say a massive thank you to all of our panelists for joining us this afternoon, sharing their experiences and thoughts with us. If any questions come up from the audience afterwards, you can either get in touch with us via our social media or via the Discover Materials website, which, like I said earlier, is in the process of being remade and hopefully will launch early next year. So thank you again to today's panel. We'll hand back over to Chris now to close out today's talks.